So, hey everyone, myself Surya, and I will be the trainer for this course delving deep into Hadoop. And welcome to the course, first of all. This is a demo video or a demo session, I would rather call it as. And I'll tell you what we are going to do in this demo. I'll set the context, and then I'll talk about few of the jargons of Hadoop, and then I'm gonna talk about what all activities are we gonna perform in this course. I'm gonna walk you through the course contents, and finally I will be conveying what all when are we going to get started, right? Which is actually from tomorrow. Okay. So first of all, coming to my technical background, because this is the first time we are interacting, right? So I'm someone who is working on Hadoop. I would say data analytics and core Hadoop for the past 4.5 years, close to 5 years. And I'm someone who is having a business degree with Harvard Business School on business analytics. And I've got certification from all the distributions, let it be Cloudera or Hortonworks or the mapper of Hadoop, right? And so why did I name this as explore the data analytics for them? And why did I give a tagline for Hadoop? Delving deep into Hadoop as explore the data analytics. Basically, in this course, we are not just going to learn about Hadoop, but rather we are going to explore analytics area as well. The data mining, because one has to understand Hadoop's main area is analytics. So how are we going to do analytics? Few analytical algorithms. I will give you a high level overview on data mining, heavily used data mining algorithms as well, apart from Hadoop. So that's the main reason why we have given explore data analytics, because in Hadoop, it's not just about doing the technical part as a technical development of Hadoop, but also it's very important for one has to have a basic overview on data science as well. So that's something that I'm going to cover in this course. And coming to this course, it's 40 hours course, wherein there will be a session on every day, apart from, I'll give one day off. Either that could be on Saturday or on Sunday. That will be based on your availability. So ideally, it's a 6 days course, right, throughout the week, and it's totally 40 hours course, right? What all things are we going to do in this 40 hours? I'm going to convey in a while. So it's a 40 hours course, and the main motive of this course is to give as much as practical exposure as possible. That means the architecture wise discussion and everything, that will be only to the level where you require, right? I would give you some books to go and read, but I would rather concentrate on different use cases and the case studies that happens in the real time. So one has to be prepared to spend at least 40 to 45 minutes on daily basis to work on what we are doing, and also different case studies that I would be giving. So that's about the expectation from the candidate who is going to continue in this course. And coming to what all activities are we going to perform in this course? See, like I told, the main motive of this course is to give as much as practical exposure as possible. So on daily basis, there will be 1 or 2 case studies for everyone to answer, right? So that's one thing that you have to do. And second thing is, probably after 10 days or 12 days after the course begins, I'll give you a use case that's like a project that you have to work on. Maybe if this batch is having a count of 15 people, let's say, I would split them into 7 and 7 batch, right? And each batch I will be giving some task. I will set some idea which covers both Hadoop and data analytics, right? And you are supposed to develop that particular product and come back with your resolution, or the solution. You will be working as a group. At the end, after 10 days or 15 days, we are going to integrate both these particular phases that both the batches had completed, and finally we will be coming up with the documentation. So the main reason for this exercise is to give you some exposure on how things works in real time on Hadoop, because it's a distributed framework, right? It's not the development part or the how you approach for a solution is quite different from how you see it in traditional things. I mean, the real time usual things how you work on, there will be slight difference in a Hadoop world or big data world. So to be aware of that, this exercise is going to help you a lot. But again, it all lies on your timing, and you're supposed to spend like 45 minutes to 1 hour per day apart from attending 1 hour session. So that's the expectation from the candidates. So coming to this course, like I told, I'll first initially walk you through a few jargons of Hadoop, right? And then what I'm gonna do is I'm going to I'm going to walk you through the course contents of what we are going to cover in this course. And also I'll show you few use cases that my previous batches are working on, or how I already worked on, right? That gives you some basic overview on how things works out here. Okay. Now, to start with, I'll start with what is big data. Maybe few of you have already attended my demo, and few of you had already watched my demo video, but rather it's like a repetitive thing for first 10 minutes or something, right? Just bear with me for 10 minutes or 10 to 15 minutes, and then I'll walk you through the course contents that we are going to cover in this demo, right? In this course. So first of all, I would cover what is big data. But why do we require to learn big data when we are attending a course on Hadoop, right? So I'll tell you, if you've seen about Hadoop, you would also hear this term big data. Why? Because first let's understand what is big data, then we'll understand why always Hadoop and big data goes hand in hand. Big data is a term that we usually use to denote large data sets. When I say large data sets, it could be in the range of petabytes, hexabytes, zettabytes, or even more. And this big data cannot be stored, or rather analyzed, in any of the traditional RDBMS. One has to understand that. So big data is usually a term used to denote large data sets, which could be in the range that is beyond the capability in storage and analysis of a traditional RDBMS. But my question is, why is RDBMS not able to store or analyze big data? Right? Because you understood big data is not something that can be stored or analyzed in big data, but why? The answer is simple. RDBMS is not designed to store or analyze big data. One line answer, I would say. Because of its architectural limitations. It's not designed for such huge data. It works pretty much better when you have terabytes or gigabytes of data. But you can ask me, hey, what's the point? You can simply add a hardware, right? You can simply add a hard disk and make a RDBMS to store petabytes or exabytes of data, right? There is no constraint of adding a hard disk. Of course, you can add it to any RDBMS. Probably a zettabytes of hard disk you can add, and you can ask a hard RDBMS to store it. Yeah, that sounds good. But what do you do after storing? Is it just the storing that you're looking at? To me, storing is only the part, but the majority lies in analyzing that particular data, isn't it? So you have to analyze the data and dig out the results. You have to dig out the insights of the data. That's what any organization would like to look at. Why would Yahoo store petabytes of data per hour just for the sake of storing? Right? It's not just the storage. Storage is a very minimal part. But the biggest contribution goes to your analytics that you are performing on top of it. You have to dig out the insights from that particular data. You have to mine the results from that particular data. But will RDBMS be capable enough to work on petabytes or zettabytes of data to do some data analytics or data mining or whatever you call it as? The answer is strict no. Because the architecture of RDBMS itself will not support analyzing such huge data sets. Right? You add hard disk, which will accommodate you to store petabytes or zettabytes of data. But at the end of the day, you'll not be able to analyze your data, which is the actual thing that is required from the data that we store. There you go. You got the answer. So, big data is a term used to denote large data sets, which could be in the range of petabytes, hexabytes, zettabytes, or even more, right? And this cannot be stored or analyzed in RDBMS. Even storage is pretty costly. See, buying a hard disk and adding it is not as simple as we are thinking here. It has its own limitations, it has its own budget constraints, it has a lot many things on top of it. So, RDBMS is not a fit for big data. Then who is the one who can hold in both in terms of storage and analytics? I would say that is Hadoop. And I would again say it's not just Hadoop. You have a lot many things available in the market. You have Cassandra available, you have MongoDB available, you have Vertica available, right? You have Hadoop also available along with them. But why is Hadoop so popular when you compare it with other technologies or the other databases available in the market? I would say simple reason is the way Hadoop operates and for the cost that Hadoop is coming up with and the architecture that the Hadoop is holding is giving a lot more prominence to Hadoop, which is making it popular in the current day market. That would be the only reason I would say. I would say Hadoop is coming for cheaper cost. I would say Hadoop is so robust and Hadoop is so flexible that it can deal and analyze the big data. That's the simple reason I would give. But of course, even I see Cassandra as powerful thing and MongoDB as powerful, but they have their own limitations in what they operate for. So finally, I came to a conclusion that Hadoop is one of the better technologies available in the market to deal with big data. But I'm never saying Hadoop is the only technology. It's a better technology that we have in the current day market to deal with and analyze the big data. Okay, so that's about why big data and Hadoop goes always hand in hand. But you have to understand one thing. What is this data mining? I was telling that storing is only the part, data mining or the data analytics is the actual part, right? So what is this data mining? Data mining is a term used to denote data science as well. So what is that? It's simple. You have very huge data sets, which you can coin as big data. You run some algorithms on top of it. It's not just for the sake of just running an algorithm. You run on top of it and you mine the results from it. You mine some insights from it. That's why it is called as data mining. The term is denoted as data mining. But how do you mine the data? Right? So there will be algorithms for that. How to mine it. And when you mine the data, you'll get some insights of that particular data which can improve the performance of your organization or it can improve the customer experience as well. Right? For example, Apple is analyzing its sales. Let's say it has taken two instances, North and South America. Apple had observed that in North America, the sales of Apple are predominant when you compare it with South America. Now, what Apple has to do is, it has to take all the transaction details and see that why South America is behind when you talk about the sales of Apple iPhones or something. There could be a number of reasons. For digging out that reasons, it has to do further analytics on what all other products are available in the current day market that people are opting out apart from iPhone in South America. Why is that so popular in North America? Why is it not in South America? They have to dig out those insights to understand why they are behind in South America, what they should do in order to improve their sales. As simple as that. So why are they doing the data mining here? They are digging out the results just to increase their sales. So at the end of the day, when they perform analytics on top of their data, they would understand what customer is looking for. Maybe some features are missing in iPhone, which they are getting it for cheaper cost in other mobile. Maybe they have to concentrate on the futures, and they have to also think about their pricing, right? So that's what current Apple team is doing because of their degrade in the sales. I mean, serious downfall of the sales with respect to iPhones or Mac products. So this analytics will help the organization to grow back if they are missing something, right? So that's about data mining here. So let's discuss about what is Hadoop. But before that, I'll stop here for a couple of minutes to answer your queries if you have any. You can either raise your hand, you have an option to raise your hand so that I'll unmute you so that you can post your questions, or you can ping that question in the chat window as well so that I'll take it from there and answer your queries, right? So Siddharth has a question here. Analysis is difficult for RDBMS. Pulling out from DB is difficult. Okay, his question is, why is analytics difficult in RDBMS? I would say, Siddharth, that's because of architectural constraint. RDBMS always holds record by record. Let's say I have a billion records in a table. When would I complete some analysis on top of this RDBMS? If it is going record by record. Okay. Not only that, it's about the structure of the data as well. If my structure of data is, if my data is structured data, that means it can be organized into columns and then stored in rows, that is fine. What if I get unstructured data? Will RDBMS be able to analyze that? Obviously no. If I bring some log file and ask RDBMS to analyze it, it will not be able to analyze it because it's not designed for that. So all these reasons say that big data cannot be analyzed. I mean, it can be analyzed to some extent, to some formats of the data, but not everything. Right? Sumit, I hope you got my point. Sorry, Siddharth. Okay, Mukesh, just give me 2 minutes. I'll come back to you. Let me answer all the queries in the chat window first of all. So data mining is converting the data into information. I would say that you need not convert anything. Rather, you use the same data to mine the results. That's a perfect term that I can use for data mining. You need not you need not do any conversion for that matter. Rather, you mine the results from it. What are the prerequisites for Hadoop Big Data? Raj, just give me some time. Probably when I walk you through the course contents, I'll tell you what all the prerequisites and what are we going to do to gain the knowledge on those prerequisites as well. Okay? And yes, Mukesh, please go ahead.
Yeah, I have one question. Like, do we have any disadvantage for this Hadoop? If not, then why it's not spread it everywhere in the world? Why it is like a little bit better? I mean, then why do we have so many competitors? Right? Why we have MongoDB? Why we have like other you name it? Why it is like that?
Wonderful. It's a really wonderful question. But let me tell you, any architecture will have its own drawback. Right, Mukesh? And even Hadoop do have it. But again, I will take some time to talk about the drawbacks and what where Hadoop is fit into, because I have to introduce you with few architectural jargons before I talk about the drawbacks that we do have on Hadoop. But again, Hadoop is an open source. You might have a drawback, and it is being developed and added in a patch. But still, Hadoop has limitations in what it can operate on. Right? I was talking about big data analytics, right, Mukesh? Did I ever talk about the smaller data? And did I ever say that Hadoop is a better fit for smaller data? No, right? No. That could be the reason why it is not spread everywhere in the organization. I mean, every organization, because there could be many organizations who are still dealing with some gigabytes of data, for which Hadoop may not be a better fit when you compare it with RDBMS. Not only that, when you compare it with MongoDB, when you compare it with MongoDB, right, the better and classical example I give you for MongoDB is the Aadhaar card information of India. Entire Indian population Aadhaar card information is stored in MongoDB. Why is that? Why did they go for Mongo? Because Mongo is a better place where it can store documents and the data which is in JSON format. So this Aadhaar card information is in JSON format, and again these are documents. Obviously, Mongo is a better fit for this, and that's why they have gone for MongoDB. That means everyone has their own use case. That's the reason why I told Hadoop is one of the technologies available in the market, but it has a better futures when you compare it with other. Because I seriously say Mongo is only fit for document storage and JSON. But if I have to do some core analytics on unstructured data, where I have to structurize the unstructured data, I don't say MongoDB or Cassandra are the better fits. I have to come to Hadoop. There is no option for them, right? But still, Hadoop can store JSON format data and documents. But that may not be as efficient as MongoDB. Maybe this answers your question, Mukesh.
Yes, right. A lot clear.
Cool. Yeah. Yes, Raj, that's what. Just give me another 2 to 3 minutes where when I go through the course contents, right, you'll get the complete knowledge on what all prerequisites and how are we going to work on that. You know. So that's about big data and Hadoop, why they go hand in hand. Now, coming to what is Hadoop, why is it so popular? I would say Hadoop is not a database. Rather, it's not an file server as well. But what is it then? Hadoop is a framework that is built on top of Java. So the main intention of this framework is to store big data and to process big data, which is nothing but analyzing big data. So as simple as that. Hadoop is a framework that is built on top of Java, which allows distributed processing of large data sets across clusters of computers using simple programming models. That's the definition of Hadoop. So it's a framework. So when I say framework, what is a framework basically? A framework is something where you have a lot of components that are attached together, and it should be flexible enough to dispatch them at any point of time without impacting other components, right? So Hadoop has a lot of echo components I should say, which I'll be walking you through when I talk about the course contents. So a lot of echo components are there, which is making Hadoop so robust, so flexible that it is fit for many different use cases. But when I talk about distributed processing of large data sets across clusters of computers, you have to understand two things. One is Hadoop distributed file system, and another thing is MapReduce. Let me tell you what. MapReduce was so popular probably 2 years back or 3 years back. But nowadays, because of the evolution of Hadoop and the improvements in Hadoop, MapReduce has taken a back step. Now, I would see the majority of the market is going around Spark and Kafka, which are working with different architecture than what MapReduce is, right? It's not just about MapReduce, it's about Spark and Kafka nowadays. Okay, but Hadoop was primarily designed with MapReduce in the background. So let's discuss first of all what is MapReduce and what is HDFS, and then you'll understand later on why Spark has dominated Hadoop to a greater extent and what is the significance of Spark. See, I will tell you, many people take it in a wrong notion that Spark is replacing Hadoop. No, Spark is replacing MapReduce, one of the component on Hadoop. Spark cannot replace entire Hadoop because Spark is one of the component that is present in Hadoop. That's what I was talking about. The framework is a group of components. And that component, I mean, among those components, Spark is one at another component which is so popular right now, right? Let me tell you what is HDFS and what is MapReduce in very generic terms. Let's talk about a guy who is working for a construction company, okay? And his job is to lift 100 bricks from place A to place B. He has to put 100 bricks from place A to place B. But he can put only one brick per minute. So what does that say? He would take 100 minutes on an average to place all these 100 bricks from place A to place B, right? So when I say 100 bricks, my construction company wants that to be completed in 10 minutes. But that's beyond the capability of this person, right? So what I would say is, just give me a moment. Okay. What I would say is, probably recruit 9 more people. When I have 10 people in my hand, what I would do is, I would give 10 bricks to each person, and each person will take 10 minutes to place these bricks. And when I make them to work in a parallel way, my job would be getting completed in 10 minutes. As simple as that. So, what did we do here to solve this problem? We have got 10 resources where I have distributed the task among them and made them to work parallelly, and my task got completed in 10 minutes. One moment. So my task got completed in 10 minutes. So, so Hadoop is similar to that. Hadoop doesn't have a single file system. Rather, it has multiple file systems who work in a parallel manner or a distributed manner, right? So file system is what? I can term it as CPU, or you can call it as a server. You can call anything for that matter, which works in a distributed manner. So Hadoop distributed file system is group of file systems who work in a distributed manner and achieve parallelism, right? So if a task is taking 10 hours, maybe with Hadoop I can complete it in 1 hour or less than that, depending upon how many resources I'm using for that. So here you understood what is HDFS. It's a distributed file system wherein there will be group of file systems who would be working in a distributed manner. But we have to look at one underlying thing here, which is called MapReduce. When you look at MapReduce is a programming model, right? The programming model helps us to distribute the task among multiple file systems. Because I have 100 bricks, I have to split it among 10 people. So this mechanism of splitting and routing the task to different file systems will be taken care by mapper and reducer, for which you have to write your own logic. That's why I call MapReduce as a programming model. It's a programming model where you have to give the coding part, and which you have to primarily give in core Java. So there you go. Hadoop is a it's a framework which has two major ingredients. One is HDFS and another thing is MapReduce, which allows you to store and analyze the data in a distributed manner using this Hadoop distributed file system and MapReduce. But I would say MapReduce has taken that step nowadays, right? Even see, my course goes with the current market. Earlier, I used to give almost like 8 to 9 days for MapReduce. Now, I've cut shorted it to 4 days. Because, when you go for an interview, people may not ask you more about MapReduce. Rather, they would ask you about Spark. They would ask you about Kafka. They would ask you about other echo component which is so popular. So it's better to concentrate more on that, right? Because we already know that there are few components being replaced by other, so we will give least priority to that. And because we are going to prioritize our course, which one to spend more time, Obviously, that depends upon which will be more beneficiary to the candidate when they attend the interviews or when they work on real time. So that's about Hadoop and MapReduce. So I'll stop here for a couple of minutes before I go to the walkthrough of the course contents. Any questions, anyone? You can either raise your hand or ping it in the chat window. So as I don't see any questions here, oh, there is one person who has raised the hand. Let me check who has raised. Oh, okay, fine. There is no one who has raised the hand. So I assume that everyone is comfortable so far. So Mukesh, you have any question, Mukesh?
Yeah, actually, I have.
Yeah.
So, I just said like the MR thing. Is it like out of market now, or it's still there, and the other people have taken it?
It's still there in the market. See, MapReduce is a programming model. It's still there in the market. But there are other architectures in Hadoop which is being used rather than MapReduce. I mean, it's still there.
Which are better? Which are better?
Absolutely, they are better in terms of performance, in terms of execution.
Okay, got it. Yeah.
So I hope everyone else is clear. So I'm proceeding further with the course contents walkthrough. So see, that's what I was telling. Hadoop has two architectures. The older 1.2 architecture, which predominantly worked on MapReduce. Now 2.2 architecture, which has got a lot of changes, which is called YARN, yet another resource negotiator. So these are the two architectures that we would be initially targeting. I mean, these are the only architectures that we do have on Hadoop. So we would target on the architectures for the first 5 to 6 days. And on top of this, Hadoop has three prerequisites, I would say. One is Linux, another thing is core Java, the third thing is Python. Okay, so three important prerequisites for Hadoop: Linux, core Java, and Python. And what we are going to do, I mean, for example, I have a candidate who is pretty much new to Linux and he is good with core Java and Python, let's say, or any of the probabilities, probable combinations of these three. So what we are going to do is, starting from day one, we are going to work on case studies of all these three prerequisites. As an initial step, maybe after tomorrow's session, what I'm going to do is, I'm going to share you with all the three prerequisites, let it be Linux, core Java, or Python. I'm going to share the videos of mine, like, like the recorded videos of mine, so that you can watch them first of all. Once you watch them, when we actually start the course, right, I'm going to give you different case studies on daily basis. Every day there will be a case study for you to work on, right? Probably I'll start with a very basic level case studies and I will increase the proficiency. So that's the way, I mean, because see, understanding the basics, that particular videos will help you out. It will brush you the basics. To one, become someone who is proficient in any of these prerequisites, it's about working on them and answering the case studies, right? It's about actually practically having the knowledge on them rather than having some bookish knowledge. So that's what we are going to do. We'll work on different case studies on daily basis on these prerequisites until we complete the architecture. Maybe first 10 days or something, first 8 to 9 days. Second thing, I would be I would be also, after 10th day or 12th day, I would share you some idea on some product development, I'll call it as. Let me show you a few examples here. If you look at my previous batch, I mean, it's like two batches per year, we were working on some social media analytics. It's about using Hadoop. You analyze the data of social media data, let it be Twitter or Facebook, and you come to a conclusion like any product you give, what is the customer sentiment of that particular product? Let's say you have launched a new uh, finance product. I mean, let's say, and what are your customers thinking about it? Is it going positive way? Is it going in a negative way? Is it are your customers neutral about it? So you wanted to analyze that. Simple. You would work on the social. I mean, first you have to take the social media data and pre-process it and do some analytics on top of it, right? So this is what one of the case study that my previous batch people had worked on. Or if you look at the current uh, the current batch who is working on, let me show you an email that they are working on. Uh, see, they're working on some recommender system, right? So I've started. I mean, it's just the 15th day of their course, so they have started doing the groundwork. They're doing what is a recommender system, what is this collaborative filtering, and what is this alternating least squares method, which is the algorithm that we are gonna use. They're doing all the groundwork. So everything is like combination of Hadoop and analytics. They do this on top of Hadoop, and they do it in terms of analytics. So that gives you some practical exposure to analytics as well as Hadoop. So this is another activity that we would be performing, which is nothing but the product development part, right? That we would be starting somewhere between 15 session or somewhere between after 10 session or 12 session. Until then, we would only concentrate the case studies on the prerequisites of the Hadoop. Okay. Once the architecture is done, I'll slowly take you to the practical aspects of Hadoop. The first thing is cluster installation, because we will be discussing about a lot of theoretical aspects of architecture, right? So to correlate them practically, this cluster installation will work. So whatever we discuss, what all the architectural concepts we discuss, when we install the cluster, they would be crystal clear. So that's the main reason why we are doing this installation. But let me tell you, this course primarily concentrates on Hadoop developer and analyst role, right? And there is another role called admin, which may be to a percentage of 20 or 15 to 20%, But my majority concentration would be on 80%. I would be concentrating on analyst and developer, okay, which is the current leading thing in the market. I mean, the data analyst or the Hadoop senior developer or a developer. So that's the main aspect that I will be concentrating on. And we will be doing the cluster installation, which is an admin activity though, but that gives you a better picture on the architectural aspects that we discuss. And there comes your HDFS, Hadoop Distributed File System, which will have its own commands that we would be dealing with, and we will start with the very basic commands to a level of where you deal with the very advanced commands of HDFS as well. And there comes map reduce. That's what I told. I used to spend almost like 9 days or 8 days earlier, but I will only cover in map reduce the most required items or most required concepts, right? Rest all things, I will let's quickly wind it up with respect to map reduce, because I'll cover all these phases like mapper, reducer, splitting, sorting, suppling, and partitioner, combiner. All these things will be covered, but I would limit the use cases basically, because when you go to real time, when I know that there won't be much of scope for map reduce nowadays, so it's a waste of time. So this is what I was talking about, the Hadoop Echo components. The primary and very heavily used component nowadays is Hive, which is a data warehouse on top of Hadoop. So what I would do is, coming to this component, right? I'll prioritize which one. It's based on which one is heavily used. If I say Hive, it's very heavily used in the current day market. So we would look at Hive in and out. We will look at it to a level where you will optimize. You look at the optimizations. You will work on how the products will be developed on top of Hive. All these items will be discussed when it comes to Hive. And then comes PIG, Pig, right? Pig is a data flow language. Data flow language in the sense it's close to programming language, which we call it as Pig Latin. And what it is used for is It transforms the data. Let's say I have unstructured data. If I have to structurize the data, it can be used. But again, it's losing its prominence. Again, Spark is dominating Pig, but it's not as it is not being as dominated as MapReduce is, but still Pig is being used in the current day market. So we will spend some time on Pig as well. And comes again a very easy, a very lightweight, but rather very heavily used component called Scoop, an SQL import export utility. If I have to bring in the data from any RDBMS to Hadoop, I would blindly go with Scoop. Scoop is very flexible, very lightweight, and very easy as well, right? So hardly if you spend 2 to 2.5 hours on Scoop, you will be an expert in Scoop, right? So that's the easiness that you find in Scoop. So we will concentrate more on Scoop as well because it's very heavily used and very popular. I would say very popular HBase, a NoSQL architecture. Why is it very popular is when I talk about HBase, I'm not only talking about HBase, I'm talking about other NoSQL architectures as well, primarily Cassandra, which is a very popular very popular database in the current day market. So when I talk about HBase, I will give you overview on how Cassandra works as well. So that gives you a complete picture on how the NoSQLs work and why they are so popular in the current day market, right? So I'll talk about HBase, and on top of HBase, I'm also going to talk about a JDBC layer called Phoenix and Flume. Flume is another component. See, I told Scoop, right? When you have data in RDBMS to get into Hadoop, you will use Scoop. What if I have data in any web server? If I have to get the data from Twitter, that's when that's when Flume will be used. Flume will be a component that can be used for the data migration other than RDBMS, right? And then comes the most popular and most heavily asked component right now, which is Spark. So Spark is something that we will concentrate more on, and it's an RDD based application, resilient distributed data set. So we would talk about all the functionalities available in Spark. Let it be Spark shell, or let it be Spark application development, or let it be Spark data frames or machine learning capabilities or streaming. We are going to talk about all these things with respect to Spark, right? And then finally, we are going to discuss about Kafka. Kafka is a messaging broker, which is again, these are like not technical components. When I say Flume and Kafka, these are not technical components. These are just the uh, configurational components. Well, they are that you need not spend more time on this Kafka and Flume. Whereas others like Hive, Spark, HBase, Scoop, you need to work technically, so you have to spend some time. And if you look at every component, at the end of every component, you will find some case study that you have to answer, right? So that's what I was referring to. Every day, almost every day, I would say, there will be case studies that you have to answer apart from the product development that you would be doing, right? Product development is something that I won't consider as a case study. It's a responsibility. If you have to have the practical exposure, I would definitely ask to spend some time on product development as well, apart from the case studies that I give you on daily basis. To me, the most important thing is you are supposed to answer every day's case study. Okay, so that's totally about the course, and the course timing would be the same time, 6:30 a.m. IST or 9 p.m. EST or 8 p.m. CST. So this is the timing, right? Today's timing will be the actual timing, the fixed timing for every day session, right? And I'm going to take session tomorrow as well, which will be your Thursday evening or Friday Indian morning, and then we would connect back on Monday, which is the Tuesday morning of Indian folks. So because it is freshly started, right? I would like to give some time for other consultancies as well, so that they will bring their candidates, and it's just a kind of just giving some time for them to decide. So today and tomorrow you can use the same meeting link, and you can join on tomorrow's session as well, wherein I'll talk about the jargons of Hadoop and where Hadoop is fit into. And starting from Monday, we are actually entering into the actual course of the Hadoop. So that's the briefing from my end, and I'm pretty much done with my demo. I've covered each and every aspect that I would like to cover. So if you have any questions, probably you can ask me. I'll wait here for another 5 minutes. Oh, yes, Sidhu. Sidhu,
Yeah. I have a small question, like, I mean, is there any possibility that, you can get into, like, 6 to 7 IST? Is there any chance?
oh, 6 to 7. I cannot promise, but let me talk to Tom as well on this because I've conveyed the timing for other folks. But let me talk. Let me check on that. But I'm not confirming anything. For now, it's 6:30 to 7:30, right?
Actually, yeah, but I have, like, a small class from 7 to 8:30, so
Oh.
in my college. Is there any chance, like, if it goes from 6 to 7?
Let me check that because I have other batch as well which I have to map accordingly. So I'll convey that to Tom.
And one more thing, can we get, like, any recorded films on your classes?
Yes, if you are missing any day session, definitely you'll be getting a recorded demo for sure.
Okay. Can I get, like, today's because I missed my.
Yeah, sure. I'll be sending it across. I'll definitely send it across. Yeah, no problem. And yes, Mukesh, go ahead, sir.
Yeah, I have a question, like, as you said, like, a prerequisite for Python, for Java, and Linux. Like, how good one person should know? Like, as a, like, even though I'm from computer background, like, I worked as a web developer for 3.5 years. So, as a coding extra knowledge, I know a basic level, but I'm not very good at it. So, I thought it's a good question. If it is even the prerequisite, how much one person should know about it?
Okay, wonderful question. I'll tell you in each of the technology. I would say core Java, if you are at least basic at a basic level, I'm fine with it.
Yes.
Okay. But when it comes to Python and Linux, I would ask you to little concentrate on it. Probably, I don't expect everyone to be an expert in this. After I give you the videos and afterward you work on the case studies, but you will be in a position where you'll feel the comfort zone when you go through the any of the Python code or Linux. So that's what I'm anticipating that everyone to be in. So you should be in a comfortable position to look when you look at a code, you should be able to understand it. You need not Google it directly. Okay, this is doing this and this is doing this. If you are at that position, that's fine. You need not be an expert either in Linux or in Python. Okay.
Like, I don't know about Linux at all. Python, I guess, like, a few of my roommates, they're like learning right now. So maybe I can grasp that. But about Linux, I guess
I will take care of that, Mukesh.
Yeah, that was this question I have. It. And another question, like, I'm right now in USA. So, like, every day my class would be at 9 o'clock.
Absolutely, yeah, 9 p.m. EST.
Okay, yeah, got it. Thank you very much for that.
Yeah, no problem. Okay, Sumit. Okay, Ashok's friend. Okay, is there with me? Time of the class. Oh, sure. Yeah, we can talk, Raj. That's fine. No problem. And yes, I would be sending for all of you the demo video that we have taken right now, right? And yes, you can use the same meeting link tomorrow as well, which would be at the same time, 9 p.m. EST or 6:30 a.m. IST. And every one of you who had missed the session, probably the first 15 minutes or in the middle, you will get the recording today. I'm gonna share it across. But Kumar, I mean Prasanna, can you confirm from which consultancy you have joined, please, so that I'll take care of the sharing of the demo video. Okay. For others, if you don't have any further questions, That's it for now from my end. You can come back to tomorrow's session using the same meeting link wherein I'll talk about the prerequisites of Hadoop, right? So, not required. I mean, you've already registered for that, right? I mean, you'll get the reminder tomorrow as well. The same link will remind you tomorrow probably. Even now, probably it would have already sent a reminder to you on regarding tomorrow's session. Okay. So thanks everyone. Right. I hope you enjoyed the demo session. Right. Let's come back tomorrow and discuss further on the prerequisites of Hadoop. So thank you and bye bye. Good night. Yeah. Yeah. Thanks, Mukesh.